to part 2 notes. So from a point 100 meters from the base of a tower, the angle of elevation to the top is 42 degrees. Find the height to 3 significant digits. So I have some tower here. Okay, so there's my tower. And I am 100 meters from the base. So that's 100 meters from the base. The angle of elevation, when they're talking about angle of elevation, that means that you are standing somewhere and you are looking up. That's angle of elevation. So between my 2 arms would be my angle of elevation. If they were talking about angle of depression, you do a horizontal out and go down. So depression would be down. Depress is down, and up would be elevation. So I'm standing there, I'm looking up. So this angle here, looking up, is 42 degrees. I'm 100 meters away. I want to find the height. So I want to find this, or I can call it H if I want. Okay, so I want to find that height. So I have an angle here, and I have an opposite side, and I have adjacent side. So you should know that opposite is tangent. So the tangent of 42 is equal to my opposite side, H, over my adjacent side, 100. So if I were going to solve this, if I'd multiply each side by 100, I'd get 100 tangent of 42 is equal to H. Pick up your calculator and make sure your calculator is in degree mode. So make sure mode, I'm in degrees. So now I'm in degree mode, and then just put 100 tangent of 42 into your calculator. So I am going to do 100 tangent of 42. And I got 90.0404, repeating for a little while, or 90.0. So there's my height. So the tower is about 90 meters high. Always draw a picture, I think it helps. The next one, from the top of a lighthouse 54 meters above the sea. So we have a lighthouse that's 54 meters high. So I have some lighthouse here. There's my lighthouse. And it's 54 meters high. So there's my lighthouse. Okay? The angle of depression of a buoy is 17 degrees. So there's some buoy out here somewhere. I don't even know where it is. There's a buoy out here. There's a buoy in the water right here. Okay? So my angle of depression, I'm going down, is 17 degrees. Find the horizontal distance from the buoy. So I want to find the distance, this horizontal distance here. And I'm going to call that x. Okay? So if this is 17 degrees, that is 17 degrees. 2 parallel lines cut by a transversal, the alternate interior angles are congruent, okay? Or I could have found this angle right here, 90 minus 17 would give me 73 degrees. So I can use either angle. I have 2 sides of the triangle, not the hypotenuse. So I have 2 legs of the triangle, not a hypotenuse. So only trig function I could use is tangent, or you could use cotangent, but if you look at your calculator, the buttons that are really easy to get to are sine, cosine, and tangent. So I can solve either the tangent of 73 is x over 54, or the tangent of 17 is 54 over x. Either one will get me there. So if I were solving the first one, I would cross multiply and get x tangent of 17 is equal to 54, and then I'd solve for x, and I would get 54 divided by tangent of 17. This one, if I multiply each side by 54, I'd have 54 tangent of 73. So if you put that in your calculator, either one of them, you will get 177 meters. So try them both ways. Put 54 divided by tangent of 17, and do 54 times tangent of 73, and see if you get the same answer. You should. From the top of a very tall lighthouse, so there's my lighthouse, overlooking a lake, so that blue dotted line is my lake. Jack, see Jack's on top of that lighthouse, and he's watching a boat sailing directly towards the lighthouse. So there's that boat out there towards the lighthouse. He notes that the angle of depression, so this angle down here, is 27 degrees. So this angle is 27 degrees. Later, it changes to 40 degrees. So this boat is moving, 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 and then now it's closer. So see, it looks bigger now that it's getting closer. Now, the angle of depression is 40 degrees. Okay, so if this is 40, this one down here is 40. He is 120 feet above the lake. So he's 120 feet above the lake. How far did the boat travel during that period? Okay? Well, when you look at this picture, I have a right triangle here. The blue is a hypotenuse. I have a right triangle here where the red's the hypotenuse. So if I can find this leg, and I can find this leg right here, I can just take the difference of the two, and if I find the difference of these two, I'll be left with that. The base of the red triangle minus the base of the blue triangle will give me the green. So let's cut it out there. So that's right, I need to calculate the two distances and then subtract the two. Both distances we calculate will give us a distance from the boat to the shore at different times. So by subtracting those two distances, we'll see how far the boat traveled. So that's what we want to do. So first of all, we want to find out the long base first, okay? The big triangle, that was the red one, okay? So let's figure out how we do this. I have an angle here, I have an opposite side I know, and I have an adjacent side that I want to find. So what uses opposite and adjacent? And I hope you tell me that it is tangent. Okay? So when I do this, I will do the long distance. And then I will do this short distance. And you'll use tangent again. It's the same thing. Okay? So let's find the distances. Calculating the distance to the shore from the first observation, so this long line, I did it as red the first time. I said you would do tangent. So the tangent of 27 degrees is 127 over this side here. And I'm just going to call that side x. Okay? So I can figure this out by doing 120 divided by the tangent of 27, and that'll give me, oops, sorry, that'll give me my x. If you wanted to, I could have found the angle up there, which is 63. So I could have done this also. It does not matter. But either way, you will get about 235.5. Okay? So if you do this way right here, you do 120 over the tangent of 27. So let me do that. Grab my calculator. And like I said, on the calculator, you would do tangent, 120 divided by tangent of 27. So 120 divided by tangent of 27. And there I have 235.51. I'm going to store that somewhere. And here's what I can do. I can store it as TO. And since I called it X, I'm going to store it in X. So that's an X there. So it's there for later. The next one, the distance at the 40 degree. You could do tangent of 40 degrees is equal to 120 over the distance. Okay? Or if you don't want to do 40, you can do this angle 60 here. Either way, whoops, Either way will give you the right answer. You can do this here too. Or 50, I said 60, 50. Because 90 minus 40 is 50. So tangent of 50 is equal to y over 120. Like I said, I call this distance y. Well, let me do that in my calculator. So I'm going to do 120 divided by the tangent of 40. 120 divided by the tangent of 40. And with your calculator, you do not need to end your parentheses. It knows at the very end. You do have to end them if it's in the middle, but at the very end, you don't need to end parentheses. The calculator knows. So this you had about 143. And that's what I should have here. Okay? And now, to find the distance, just take x minus the y. Okay? So I'm going to take my x. So I'm going to get my x term, which is green there. I'm going to do x minus. I didn't store this, but I could do this if I want to go back up and grab it. And I didn't have to store this one. I could have grabbed it. And you end up with about 92.5. When you do it, you should have about 92.5. Okay? Whoops. So the boat traveled about 92.5 feet. Now, like I said, on your calculator, if you didn't store it, I could have gone up and grabbed it. I could have used my arrows. And if I wouldn't have stored it here, I could grab that and then do minus. And then grab this one. And that works too. So, but sometimes I think it's easier storing it. Okay? Look online. The homework is written online.